All right, guys. So hopefully you looked at all the other stations. You kind of did the same format, telling me what kind of interactions there are. If you ever need to pause the video and retry to do it, you can. Maybe you'll fix the other ones once you see how I answer 3 and 4. I'm going to do both of them at the same time. So looking at 3 and 4, I'm moving my files here. So 3 and 4, very similar scenario. It's a block on a ramp, but one of them, it's supposed to be not moving, and the other one, it's sliding down. So one there's movement, one there's not movement. What changes? So I'm in the Word version. So and here's a helpful OneNote tip. If you double click anywhere, you can start typing where it's at. All right. So there is a contact interaction. If there's ever contact, there's an interaction. And I think most kids, after seeing what we did for station 1 and 2, they will agree it appears the block compresses the ramp. If you look at the binder that I'm using as a ramp, you can see that it deforms a little. It's actually easier to see than like this table in the block. But I think most kids get that. Now, when we ask, there is for the block sliding down, we'll say the same thing, there's a contact interaction. Now, most kids, they agree that whatever was in 3 is in 4. It appears the block compresses the ramp, but now the block is sliding. And let me just specify too, I'm not sure if I did in the last video, but compression, it's compressing. Stretching, it's stretching. Shearing is like in between. It's sliding. So if you think of like shears in Minecraft, shears, you run it along the sheep. So that's what shearing means. It's parallel to whatever. So most kids say they're shearing, and you can guess what is causing that shearing interaction. We would probably call that friction, but we'll leave that for later. So there is, there is also a shearing interaction as the block slides past the ramp, or along the ramp. I'll say along the ramp. All right. So before we move on, let's just make sure we understand what's happening here. So this one's compressing into this ramp. This one's compressing down. Now, I think it's easy to see this one's shearing, but I'm gonna ask you guys to think something maybe a little bit more confusing. I would also say this guy is shearing. This guy is shearing. Now, you might say, Miss Erickson, that seems impossible. It's not moving. Doesn't that mean there's no shearing? But I will argue that because it's not moving, maybe that shearing interaction's even stronger. Imagine, instead of having this binder here, it was a wall of ice. And I place the object there, and there's nothing for it to stick to, and it just slides down. And it turns out, if it's able to slide more, it probably means there's less shearing interaction than if it's able to slide less. Because there is this interaction, it stops it from moving. Remember, gravity pulls everything down. So if everything is pointed down and there is no friction, essentially everything would go down. So I'm going to add, basically what I put here, it's the same thing for station 3. So you might be noticing a little pattern with our stations. All right, if you think that changes your answers for 5 and 6, you can go ahead. I'm going to answer 5 and 6 now. Let me go to the photos. So we have this. This was a rubber band. Normally it's like this stretched, and now it's the full stretch. So, all right. I think most people can get this one. Now, when I go back here, there is a contact interaction. They are contacting each other. There's a physical contact. The mass, I'll call it an object. The object stretches the rubber band. So that's what I'll say the interaction is. Now, what's interesting actually is you could kind of look at it as the rubber band probably compresses the mass. Let me go to the photo. The rubber band actually probably compresses maybe like the top of this little part of the mass here. But let's just keep it very general. We'll just say, okay, the mass is stretching the rubber band. Very good. Well, what about this here. So I have a rope here, or strings here, and then we have the mass. So now we have three objects. And I think most people say, yeah, there is a contact interaction. The block is stretching the two strings as well. And I think I would agree with that. All right. So this may seem very basic. The middle two are probably the least basic ones, but all this may seem basic, but this is going to be very important for us to move on. And let's see what our time is. All right, we've got 5 minutes. I'm going to I'll stop the video here, and we'll move on to video 2, and we're going to talk about these interactions. Essentially what they mean are there are forces being involved here. And all right, I lied. We're going to go one more video. All right, common types of forces. And I just want us to define right now what a force is. A force, and I'm just going to go super simple. There's a lot of high advanced ways you can define this, but I'm just going to say a push or pull on an object. And that's all I'm going to say. Push or pull on an object. If there is contact between two objects, there is at least one force between them. And we're going to talk about 6 common ones. There are not just 6 forces. There are as many forces as you want. So we'll talk about how scientists define these forces. So I'll see you guys in the next video.